Y'all. Okay, so let's do this third problem. Okay, say we have x and then a positive 3 over 10 equals a negative 2 over 5. So my goal is still the same. What I want to do, I don't like that light. What I want to do is solve for just my x variable. So much better, right? That's awesome. That really does look a lot better. Okay, so what I want to do is solve for my x variable. Well, mathematically, what's going on around my x variable? What's happening? Well, I've got 3/10 being added to my x. Okay, well, I don't want to solve for x plus 3/10, right? Like that's not even anywhere that I'm going. I want just x. So if I want to get x alone, I need to move this one. I need to do the inverse. Technically, I need to do like the opposite of it, right? I need to make it go to 0. And the way I would do that is to subtract 3 over 10. Just notice when you're dealing with addition and multiplication, addition and subtraction, you use the exact same term with a different sign. And whatever you do to one side, you do to the other. So here, y'all, I'm basically subtracting the exact same thing from both sides, right? I did not touch my x. Those cancel. I did that on purpose. Equals, now here, what, 2 point, no, I'm adding. So this is like chapter 3, where we're like adding and subtracting fractions. These do not have a common denominator, so we would have to find a common denominator for them. I'm gonna come down right here, y'all, okay? So I have a 2 over 5 and I have a 3 over 10. I need a number that both of them can equally divide. If I use 5, 10 can't divide 5, right? 10's too large. But if I use 10, 10 can divide 10 and 5 can divide 10, right? That's actually going to be the smallest number that they both have in common. So that's their least common multiple. Now, 10 times 1 is 10, 3 times 1 is 3. This is the same thing we've been doing. Whatever you do to the bottom, you have to do to the top. Whatever you do to the left, you have to do to the right. You always have to keep it balanced. Here, I did 5 times 2 to get 10. Whatever I do to the bottom, I have to do to the top. These are my 2 new fractions that I'm using. I'm actually going to rewrite these right here, and I'm going to make sure I pay attention to their signs, okay? So what I have is, okay, so my negative 2/5 is now going to be a negative 4 over 10. And then I have another negative, and that 3/10 stayed a 3/10. There's no reason to change that denominator because what 5 and 10 have in common was 10. So like 3 over 10 didn't change, right? So if you look here, the same way we would look at just our regular real numbers, I've got a negative 4 and a negative 3. I know that because my denominators are the same, I keep it, which is why they have to be the same, because if they weren't the same, I wouldn't know which one to choose. Here, they're the same, so you keep it. Now let's look here, negative 4, negative 3. I'm going to go down right here, y'all. In the numerator, these signs are the same. So what you do is you add the numbers, keep the sign, and we're over our 10. So that ends up being the answer to what our x is. It's a negative 7/10. I think I was zoomed in because it was so blurry. I should probably be able to zoom out now since it's a lot more clear than it was. Okay. Okay, y'all. So there's that one. Okay. So the problems we've done so far, we have our plain x variable by itself and then something's going on around it. And so we just do the opposite of what's going on around it. And that's how we can cancel it. Whatever you do to one side, you have to do to the other. And then you just have to look to see like, okay, now what do I have to do? And if it's fractions with addition and subtraction, we know the denominators have to be the same. And like you'll notice, like it feels like every different problem has like a different rule. So I get that it's really hard to kind of keep straight. This problem, it isn't just, let me see, let me just write it. It isn't just a variable by itself, but you just need to understand the steps. Here we have 6x plus 1 equals 7x. So this isn't just like a variable by itself and something's going on around it. In 10.2, we're actually going to do like the multiplication and division of equality. Right now, 10.1, all I'm doing is I'm adding and subtracting things, and I'm trying to figure out what x is. You could go ahead and move this positive one over here, or you could notice, which I don't really expect you to notice, but what they want you to notice is that because here I have 6 x's and here I have 7, not really 6 x's, but 6 times x, and here I have 7 times x, I can actually combine these together because I'm wanting to just have one x, right? And here I have one on each side. I want them on the same side. If you do the inverse of our positive 7, it would be negative 7, right? So you would do negative 7x. And whatever you do to one side, you have to do the other. I'm just going to tell you that that would make your x equal a negative number, which isn't going to be learned until 10.2. So I'm just going to let you know there should be one problem like this on the homework, okay? What you need to do is move or do the additive inverse to the smaller value with your x, and whatever you do to one side, you have to do to the other. It is kind of annoying because it's like every other previous problem, I was looking at regular plain numbers and I was just moving them, right? This one introduced something different. You still can move it, but it'd really be unnecessary to do so. If you look right here, y'all, just look at those are called coefficients. If you have a number attached to a variable, you'll hear me say coefficients, okay? If you look at just those coefficients, 6 minus 6, that just became 0, right? So that was me using the additive inverse. That allowed that to go away. Now the only thing I have on the left-hand side is the number 1 equals. And then I don't remember exactly what section it was, but whenever we were combining like terms, you have to have the exact same variable and the exact same exponent, right? In order to like do math on the numbers, on the coefficients. And here I've got x to the first power, x to the first power, that's good. I actually can combine these. So if you do 7 minus 6, you would just get 1. And then you keep your variable, keep your exponent. You can write 1x, but you don't have to. And then look, kind of just like an extra layer of, so you believe me. I had already told you that if you were unsure, what you can always do is plug back into it, right? So I have 6x plus 1 equals 7x. My 1 is my x. So I'm going to replace it. Wherever I see an x, I'm going to put in a 1. That's 6 times 1 plus 1 equals 7 times 1. Okay, 6 times 1 is 6, plus 1 equals 7 times 1 is 7. Okay, 6 plus 1 is 7 equals 7. It's funny because the other one I did also is 7 and 7. That's just a fluke. But do you see how I plugged it in? And then that let me know that what I did was correct. Okay, so of course, now they have a fraction problem.